Here's an example. You can see I've relieved it. So now I've got a reference surface to find my center on, and I'm just going to drill and tap the 4 mounting holes for the end plates that go on these guys. It's going to be a bit repetitive. Based on the nature of the design of this particular mandrel that I made, expanding mandrel, I was worried that it wouldn't repeat because it only expands on one side, so that means the bottom doesn't. Although I made it very close to the internal diameter of this, so it's holding really well. So what I did was I centered this with my Blake coaxial indicator copy, and then I flipped the part over, put it back on, and put all my zeros back, and saw if it repeated, and it sure did, which was pretty fantastic. Less than half a thousandth, which totally surprised. I'm not quite sure why it's so good, to be honest. Anyways, I drew a line on the side, which I did not line up. That was not so smart. All that does is let me visually get my holes so they're symmetrical side to side. So I drew a line down both pieces and just a line arbitrarily on there. And then we're just gonna shift off X, shift off Y, drill and tap, and that should be that. I'm in the tapping stage and I'm using a spiral flute tap which ejects the chips, but I want 3/4 of an inch of thread, so I'm having to stop in the middle. And so here's what I do. Start it up, go in, I don't know, around a 1/2 inch, or when it looks like it could be starting to load up with chips. Then I reverse it out. I put a little back pressure on the quill. I add some more lube, clear out all the chips, and then put it in neutral. Start the tap partially in the hole. It'll do that on its own, but it's just safer so I don't accidentally cross thread, because I really don't want to screw up this part. And we're shooting for about 3/4. Got to account for coasting, and we're done. So I put a little back pressure on the quill handle, holding it a little bit in the hole so that when it gets the last thread, the quill spring doesn't rip that thread out or damage it. That's just a trick. I don't know how useful it is, but I've always done it after I noticed how hard the quill will pull up sometimes. So then I've just got to do 12 more holes and I'll be back. All right, so here is the completed parts. I just need to pop these guys in the lathe on the mandrel and do the taper on these guys. Originally, I was going to put the end caps and include the end caps in the taper, but I can't see any good way to hold it then. I guess you could use a 1/2 inch shaft, but it wouldn't be terribly stable. So I think we're going to put the taper in this, and we'll have the end caps just meet up and be flat. All right, so next up, we want to cut the taper into the sides of these rollers, and the taper is about 1/8 inch per foot. And the point of that is we want to crown this roller, so if it has a high spot in the middle and is slightly lower on the sides, it'll tend to keep the belt centered better. So yeah, we're gonna do 1/8 inch per foot, which actually works out to 52 thousandths for 5 inches, and we're gonna do 50 thousandths for 5 inches because it just makes everything easier. And we're actually going to only cut in half the length of this, which is about 3 inches. So I've got my expanding mandrel loaded and trying to get this guy so that it seats fairly centered on here. Next, we have to set up our compound for that difference. And if you happen to catch my video a while ago, I made a video on a taper setting attachment or a compound angle setting attachment. So we want the compound, it's almost going to look perfectly horizontal, because here's horizontal and I think it's like 1 and change degrees. You can see it down there. So yeah, it's like 1 and change degrees. So it's going to be hard to set. So I'll show you how I'm going to set it next. So a little bit ago I made this attachment here. It's got magnets on the back and it fits on my compound like so. And it's designed to hold a sine bar to set an angle. So if I'm going to do 50 thousandths, 10 thousandths an inch, or 50 thousandths over 5 inch, I grab a 5-inch sine bar, put a 50 thousandths gauge block under one side, and that will set my angle very close. Now, this expanding mandrel only expands on one side, so it's not the ideal way to do it because obviously the side that's expanding is slightly larger than the side that's not expanding, which means this is not perfectly aligned. I tried to make it very close to the internal diameter, and it is. It's off by a couple of thousandths. Here's a 50 thousandths gauge block, and I put it under, let's see, I want this thing, yeah, I'm tilting it slightly this way. And so to compensate, I'm lifting up this side so that I end up with a horizontal because this side's farther in. And that will get my angle right. So next I need to get an indicator on the edge of this sine bar here. All right, so I've got my 50 thousandths gauge bar under my 5-inch sine bar. Got a can twist clamp just gently tightened on the end because there's really not much force on this. This is very, very close to the rotation point for my compound. So the nod effect, like setting up your tram on a mill, the head nod, it's minimized because this is right at the point. So what I do is I set this at 0. I go down here, and it looks like I'm off by a tenth or so over 5 inches, which is way better. I mean, this isn't a precision operation at all. And you just tap your compound around till you get your 0 here. And I did that off camera because it can be a little bit tedious. What I do is it's off by a value here. I come back, reset my 0, look to see which direction it's going. Like if it's going this direction, then I know that the compound has to come back this way to let the plunger out. If it's this direction, then I've got to go this way so the plunger can go in and raise the indicator. And then I come back again and I set my 0. And when you're all said and done, if you did it right, this will be parallel to the plane of, parallel to the axis of the lathe, and you will cut the taper you're interested in. So this is 50 thousandths over 5 inches or 10 thousandths an inch. And we are set. So we're gonna cut the taper next. Alrighty, so what I'm gonna do, since this is not a super precision operation, is I took my compound all the way to one side, like so. That's all the way over. The center is about right here. So I made sure that my my whole cross slide is over just past center. Then I pulled all the way back, just to the edge. I'm setting my 0 right here, right there. So that's my 0. Then I am going to come back a little bit further, and since this is roughly 6 inches, I am going to go in 30 thousandths. And when I cut that taper, and 30 thousandths is not a whole lot, when I cut that taper using the compound, I should meet at the middle. Now in reality, this is 5 3/4, so I've got to go get the exact measurement. So the actual measurement is 0.0287 5, and we don't need anything like that kind of precision, so I'm going in 29 thousandths. And we're just going to cut this taper. And we're done. Now this one I screwed up on. I did a real stupid. I went back just to check my taper, and I set my 0 in the middle. You need to set your 0 on the edge, then go in the amount of taper, and that was after I tapered it. So I had to bring in this edge even a little more, which you can see that the clearance around the holes is not as big as I would have liked. So that was definitely a mistake on my part. But we've got it so it meets in the middle with the proper taper, and we should be good to go. The next one we're going to get right. Sure. All right, so one more time, let's get it correct this time and not screw it up. So we're in roughly the middle with the compound all the way that way. Now I'm pulling it back via the compound. We're going to come all the way out to the edge, and we're going to set our 0. Then we're going to come back a little bit more with the compound, go in our 30 thousandths. Now if I want to go in more so that this taper reaches the middle, all I have to do is go in a little bit more and it will just reduce the overall diameter. So that's what I'm going to do. Go another 5 thousandths. And I'm actually moving the compound pretty quickly. It's because I don't care if there are grooves in this. I think it might help the belt stay put. Might be wrong on that, but we could always take some sandpaper and remove that later. And we're going to call that good. I'm going to flip it over, do the other side. So it's not perfectly in the meeting in the center, but it'll have a high spot in the center and taper towards the edges. This one's going to leave a little more meat on the sides. Doing the other side to meet. So after I made these parts, and I was trying to figure out to myself, why when I went 29 thousandths did it not clean up at all in Mex? It only went in like halfway. And even at 55 thousandths, it didn't quite clean up all the way. And I tried to convince myself, well, that's the 5 thousandths variation. And that might have a little bit to do with why it's not perfectly symmetrical, or a lot to do with why it's not symmetrical. However, the fault lies in a lesson I should have learned a long time ago, which I just never seem to quite get. And I bet you viewers were out there watching go, oh, come on, you can figure it out. And when I calculated taper, that's a radial distance taper. The 29 thousandths I need to go in is radial, and my DRO measures in diametral distance. So I need to go in double, and I did not. I should have gone in 60 thousandths, roughly, actually 58 thousandths, and this is 55 thousandths. This one's a little bit more. This one is around 70 thousandths, and it cleaned up all the way. So that was my bad, and I really should have figured it out. Anyways, I thought I'd make that a little more clear to you guys. Next up, I've got to turn these discs, and I was trying to think of various ways to hold them. They're 4-inch diameter, 1-inch thick, and I need to face them and then do some cutting on the inside. Plus, I need to make one out of steel. And I was thinking to myself, how do I hold them? I could turn these jaws around, but that would ultimately end up in marking the outside of these. So what I decided instead is to pop these jaws off, and in their stead, machine some of these guys. These are machinable soft jaws, and I was thinking that might be a better approach to cutting these. So we're going to try that. I've never done that before, and it seems like it'll be an interesting solution. I can do like a 1/4-inch depth diameter for holding this stuff, and give it a shot, see how it works out. Sorry about bumping you there. So let me get these jaws on, and I'll be right back. Okay, so I got the soft jaws in place, and actually they're mild steel. They're not aluminum. You can get these in aluminum as well. And so I put a spacer in the middle because they need to be under tension when you're boring them out. And I purposely chose them so that I didn't have to remove quite as much material to be able to hold a 4-inch round. So I chose a fairly large internal spacer, but not so big that it made these unsafe. About 3/4 of the jaw is still inside the chuck, so that should be plenty good. This might be the wrong kind of insert for this because it's not very well supported, and this is really heavily interrupted. I'm going to see if I have a better boring bar that might have a stronger insert, because this is kind of ugly. All right, I found a little bit beefier boring bar. This uses a W&MG, and set my height here. with my height bar, which I've been using for a few years now. The magnet's fine. You just got to make sure to keep it clean the whole time, because otherwise you'll be off. But it works pretty darn well. I've been very happy with it. And I will set my zeros on this ugly interrupted cut. I think we're going to go in about a quarter inch, just under. So, oops, you might want it in gear. All right, let's see. So that was 200 thousandths, 30 thousandths depth of cut. Let's see if we can pull off a little bit more. So you can see what I've cut out so far. I'm just roughing it right now, but we're a long way. And I guess I should get some measuring devices out so I could measure this. One challenge with cutting this out, trying to get the size, is that I only have measuring devices that go in two, that'll do even number of vice jaws, not odd number of vice jaws. What you really need is one of those highly accurate three jaw, they have three measuring points, and they fit in for inside bores. They cost something like $1,000 or $500 a piece, and they only have a range of like a tenth or two. Yeah, I need sets of those. All I need is like $5,000-$10,000 worth of those, and I could cover my range up to a couple inches. But instead, what I did was I just guesstimated. I kept walking out the size till it was a close fit, knowing that the jaws would ultimately be able to close on it. And the more accurate, the closer I got, the less chance of like catching the edge of these on there. What I was gonna do if I couldn't quite get it right was to overshoot the size. And if I overshoot the size diameter wise, then it'll only touch in the middle. It won't touch on the pointed edge. See, if this diameter was too small, then you touch on the two outside points instead, and that would mar the surface. See, you would touch here and here first. If it was too large, you would only touch, because this would be a shallower arc, then you would only touch in the middle, and that's what I was going to shoot for, rather than under to go a little over. But instead I got pretty darn close, so I'm very excited about that. That's good. Next up, we'll just machine the parts. One more thing I need to do is I need to relieve this inside corner because it's curved and my parts have sharp edges here. See that sharp edge? So I need to trepan, and I'm just going to walk in. Just very lightly take off material until I get to the back, and then I'm going to relieve the back edge. And I might want to slow this RPM down for trepanning. This might be way too fast. Well, this is pretty soft steel. It actually went really easily. Okay. Oh yeah, that'll work great. There you go, I just took it down like another 10 thousandths. That'll let sharp corners fit right in there while still being supported by a nice flat surface. I discovered that after I tried to mount a part. For those that haven't seen them, trepanning tools are for going straight in on curves, and they work in a narrow range. This one is 100 to 140 millimeters, which is roughly 4 to 6 inches. And you can see they have a curved profile. You go above or below that range, and either the outside will rub on, the bottom, the support will rub on the outside, or the support will rub on the inside while you're trepanning. You can get away with any diameter for a very narrow range, because the end of the cutter is relieved a little bit. But if you're going to do any depth at all, you have to have the right cutter. By the way, the spacer that I put in the middle, ideally it would have been solid, except I didn't have anything in this diameter solid, and this is what I had, and it's fairly thick walled. I know it deformed a little bit, but it's not critical, so I let it go. Now I can actually tighten this and have this sit flat on the bottom. Before, it was raised up maybe 15, 20 thousandths off the bottom because of that corner radius. Now it sits flat and I can tap it in and it will rest on this little plateau on each one, which is perfect.